In this video, we are going to take a look at rigid transformations in a plane and looking at it with coordinates. So here's just some review back to Unit 1 where we looked at rigid motions and transformations. So remember that when we're doing a reflection, we reflect some object across a line. So when you're naming a reflection, you would say reflect triangle ABC across line K or L if it's labeled, or something like the x-axis, y-axis, x equals 2, etc. Translate is when it just slides, okay? So the image just slides. And so we would say translate the object along the directed line segment from what point to what point. Okay, so maybe you're saying translate triangle ABC along the directed line segment from the point 2, 3 to negative 2, 7 or something like that. Rotating, so you've got a center of rotation and you need to rotate the object either clockwise or counterclockwise around that point, and then naming either the angle that you're rotating or the degrees. So rotate triangle ABC counterclockwise using 0, 0 as the center by angle ABC, okay, or something like 90 degrees. So let's take a look at activity 1 on page 6. See if you can determine how far A is from B. So how far is point A from point B? Pause the video. See if you can come up with some strategies to do that, then come back. So in figuring out how far point A is from point B, we can't simply just count the distance because it's a slanted segment. So it's not just like a horizontal or a vertical movement that we can actually count the units. It's diagonal. So maybe you did some different strategies here of how you could come up with it. But probably the main one is by potentially finding this right triangle here of lengths that you can count and then using Pythagorean theorem. So in this, we've got a height of 3. We've got this length here is 4. And then you could do 3 squared plus 4 squared equals that hypotenuse squared. So 9 plus 16, and you'd get 25 equals AB squared. So then square root that, and you would have come up with the length of AB to be 5. So what transformation would take A to B? So a point to another point. I mean, you could find a rotation, you could find a reflection. If you found kind of the halfway point here, you could reflect it over a specific line. So maybe you said reflected over the perpendicular bisector of segment AB. You could also talk about a translation, just sliding it, okay, from the point negative 3, 5 to 1, 2. So if you're doing a reflection, remember you'd be saying over the perpendicular bisector of AB. Okay, you could be looking at a translation on directed segment from, and then name the 2 points. So we want to move A to B. So that would be negative 3, 5 to 1, 2. All right, then let's take a look at the next activity on page 7. So if you're in class or if you have these materials at home, you're going to want some tracing paper. And first off, we want you to predict, so guess where you think the transformation is going to land, then actually carry out the transformation. So predict first, then actually do it, so that you can think about what's happening before you actually perform the action. So go ahead and look on page 7, and it gives you a few different transformations to complete. So do that and then come back to the video. All right, so number 1 asks you to do 2 transformations to figure H. So the first one asks you to rotate it using 2, 2 as the center. Okay, so we're rotating with 2, 2 as the center. So this point's gonna stay the same. And then we wanna be going clockwise. Okay, and remember clockwise is this way. So we're gonna wanna be moving each of these points 90 degrees, okay, clockwise. And you could have used tracing paper, okay, or some other strategy there to get that. But that would be rotating H 90 degrees clockwise. Then we want to translate the image by the directed line segment 2, 0 to 3, -4. So let's take a look at what that line segment looks like from 2, 0 to 3, -4. So this is the line segment that we're going to be translating each of these by. Okay, so it's going to move that point to here. And then if we kind of just, you could just, if I can just pick it up, right, and do this to each one, you can also look at it's going over 1, down 4. Or if you had tracing paper, you're just going to move it along that line. Okay, so then this one's going to go over 1, down 4. This one's also going to go over 1, down 4, and you end up with this new shape. Well, not new shape, I guess, but here's your image. I'll draw it a little bit better and then label that R. Then we can do number 2. Ask you to go counterclockwise. Okay, so counterclockwise would be this way, using 0, 0 as the center. Oh, and this is missing something. So we actually first need to reflect. Let's get that in there. So reflect H over the y-axis first, and then rotate the image. Okay, so first reflect H over the y-axis. So reflecting over the y-axis. So y-axis is this vertical one. So we're going to reflect over it as if we're folding it over. So this one is 2 to the right. So that point's going to be 2 to the left. This one is 4 away. So we're going to go 4 away, 2 away, 2 away, 4 from the y-axis. So its image is going to be 4 from the y-axis in the other direction. Then we want to rotate counterclockwise using 0, 0 as the center, 90 degrees. Okay, so now here's going to be your center of rotation. So if you're using tracing paper, you could set it down and then hold your pencil at this center and rotate counterclockwise. Okay, so this direction, 90 degrees. Okay, so as we rotate this 90 degrees, rotate 90 degrees, rotate 90 degrees. Okay, rotate 90 degrees. You get this new image. Whoops, that's one too far. Okay, and get that new image, and this time we wanted to label it L. All right, so taking a look at these new figures. So what do you notice about all 3 figures? So think about what you notice about all 3 figures. So hopefully you noticed that they're all congruent to each other, and you saw that when I accidentally put the point here. So I knew that it was wrong because this side all of a sudden ended up being 4 units instead of 3 like the original image. So that clued me in that something was wrong. But so you see that they're all congruent to one another because they're rigid motions. Okay, so remember we did rigid motions, and rigid motions keep the shapes congruent in size. All right, so let's take a look at activity 3 on page 8. So go ahead, take a look at those 2 images and determine each of the information wanted in 1 through 4, and then you can come back to the video. All right, so this asks you to calculate the length of each of the sides of the triangle. So you can just count this one is 3. You can count this one as 2 because it's horizontal and vertical. And then you could do the Pythagorean theorem to find AC. So we'll do 3 squared plus 2 squared, add those legs, square those legs and add them together. So 9 plus 4. So we get 13 is that AC squared. So then we'll square root, and that's the length of AC. So we're getting AB equals 3, BC equals 2, and AC equals the square root of 13. Feel free to use the decimal if you would like. For this one, we got 2 here, 3 here. Doing the Pythagorean theorem again, we'd get 4 plus 9. We get 13 for FD squared. So then we'll square root that and get square root 13. So we get ED to be 3. We get FE to be 2. And we get DF to be square root 13. Then calculating the measure of each angle. So we see a couple in each triangle that we know because we see a horizontal and a vertical line. So the measure of angle B is 90. Okay, and then the measure of angle E is 90. So since we've got right triangles here, then we can do our right triangle trig to calculate the measure of those other angles. So if I'm taking a look here at finding angle A first. So if I want to find angle A first, and let me switch colors here. But if I want to find angle A first, then I can just label some of these sides. Now, I don't want to use the square root of 13, so I'm going to use the 2, which is the opposite side, and the 3, which is the adjacent. So I'm going to set up a tan inverse function because this is tangent, opposite, and adjacent. So that means that the tan inverse of the opposite divided by the adjacent is going to give me the measure of angle A. And so then you type that into your calculator and round to the nearest degree, we would get 34 degrees. So the measure of angle A is 34 degrees. And then the measure of angle C, we know a triangle totals 180. So we'll do 180 minus 90 minus 34, and we'll get 56 for that leftover angle. And I'll just write that over here. We did 180 minus 90 minus 34, and that gave us 56 for that third angle. So we can calculate this for this triangle again as well. So if I take a look at angle D here, okay, so angle D, 2 is the opposite again, 3 is the adjacent. So the measure of angle D is also going to be this tan inverse of 2/3. Okay, so that's also going to be the measure of angle D. That's going to give us 34. So then the measure of angle F, when we subtract those from 180, is again going to be 56. So are these two triangles congruent? Hopefully you came up with yes, they are. And so your justification could have been numerous different things. One could have been all 3 sets of sides and all 3 sets of angles are congruent. So they have identical measures for everything. Okay, so identical measures for everything. So all parts are congruent. Okay, you also could have said side, side, side. All 3 sets of sides are congruent. You could have seen side angle side if you looked at the 2 horizontal and vertical sides. And then that 90-degree angle between them would have given you side angle side. Once you found all these angles, you also could have seen angle side angle. So there's a lot of different justifications for that. And so since these triangles are congruent, there must be a sequence of rigid motion that takes one to the other. So what is that sequence of rigid motions? So what could we do here? So again, lots of different things you could do. Okay, you could find a center of rotation and you could rotate it. Okay, you could also translate. So you could translate point A to point D. So let me type that out. So if we wanted to translate, so you could do translate triangle ABC by the directed segment from 2, 1, which is point A, to -3, 0, which is point D, the corresponding point. Then rotate A prime, B prime, C prime, that where you just moved it, clockwise, counterclockwise, around point D, 90 degrees. So that's one option, not the only option, but that gets you, it's going to take this triangle here, it's going to move it to point D, then rotate it 90 degrees counterclockwise to land it right on top of that other triangle. So how did you find the measure of angle A? So, you could have used a protractor. So potentially if you had a protractor, you could have used it since we're on a grid. So the triangles are drawn to scale. Could have done sine inverse, cosine inverse, tangent inverse. I just chose to do tan. So why can we use trig ratios? Because it's a right triangle. Okay, so because of the right angle, you can use trig ratios. If it's not a right triangle, you can't do that. Did you have to find all the pairs of angles and sides in order to prove the triangles were congruent? So no. You just needed to have all like side, side, side. So whoops. So we could do side, 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 or side, angle, side, or angle, side, angle. So just 3 sets would have worked. Okay, whichever 3 sets you wanted. And then if you have a neighbor or a friend, just share some strategies that can prove congruence with fewer pieces of information. So without having to do all of them, how could you just do a couple to do what we just discussed in that last bullet point? All right, then let's practice. Let's see if you understand the lesson. So if you're at home, work with yourself. If you're in class doing this asynchronously, work with a partner. So see if you can find a set of coordinates that forms a triangle congruent to this triangle. Okay, so find the ordered pairs, the coordinates, okay, that form a triangle congruent. Okay, so find the ordered pairs and then share your coordinates with your partner and see if you agree with them. So obviously there are going to be multiple different answers here. So you could be just kind of looking at this and mentally moving each point over if you do any type of translation. So if you're thinking, all right, so this E is -2, 4. If I moved it over 1, then E prime would be -3, 4. So I'm moving it to the left 1. So I'd need to do that with these other ones. So N is 4, 1. So then N prime would be 3, 1. And then D prime, so D is 4, -2. So to the left would be 3, -2. So that would be one that would be fine. We know rigid motions preserve congruent shapes. So these are just moving it to the left. You could reflect over the x-axis. So if you did that, you've got -2, 4. So we know it's 4 above here. So we're going to have to be 4 below. So then that new point is going to be -2, -4. Or so then for N, so N is 4, 1. So if we're going to reflect that, then it's going to jump, it's 1 above the x-axis. So now we're going to go 1 below. So that's going to be 4, -1. And then D is 4, -2. So we're going to have to do 2 above the x-axis. So instead of 4, -2, it's going to be 4, +2. And obviously there are numerous other ones that you could do. Those are just a couple examples. All right, so lesson summary. In the triangles below, they look like they might be congruent. We can compare their lengths by using Pythagorean theorem. So in this case, we don't have a right triangle. So we could just use the strategy from our first activity and create a right triangle here to measure this length. So to measure this length and this length. So we'd get 3 and 2, which would get us the length of ED. Then we could do a similar strategy here by drawing a vertical and a horizontal line that gives us AB as the hypotenuse, and could do the Pythagorean theorem again there. You know the length of EF is just 1 unit. And then you could repeat your strategy again for FD by doing a horizontal and a vertical line that create FD as the hypotenuse, and similar over here for AC, a horizontal and a vertical that gets you AC as the hypotenuse, doing Pythagorean theorem for each of those. So this is 1, 3, 1, 3. And you could do Pythagorean theorem to get that square root 10. So once you've figured out that that yellow and yellow are congruent, the blue and blue, okay, and then EF and CB are both 1, then you know all 3 sets of sides are congruent, so the triangles are congruent by side, side, side. Since the 2 triangles are congruent, that means there's a sequence of rigid motions that takes one to the next. So they've provided a possible sequence here. So for them, they decided to reflect it across the y-axis first. Okay, so reflect ABC across the y-axis, then translate it 2 units to the left to have it land right on top of triangle EFD. So hopefully after this lesson, you can prove that triangles are congruent using coordinates, okay? And then you can reflect, rotate, and translate figures in the coordinate plane. So you can go ahead and look at this cool down and try that on your own to decide if you understand the lesson or if you need to reach out and ask some questions.